introduce him. Dr. Ajay Deshmukh sir did his PhD in year 2006 from IIT Bombay in Instrumentation Engineering and has over 35 years of rich experience in academic community research and industry collaboration. He currently serves as the founder director of Resilience Automation Pune and is also the director of the Center for Industrial Mathematics at Bhaskaracharya Pratisthana Pune and an adjunct professor at Dr. Bhivarabai State University. Over the years, he has worked as a professor, principal, and academic leader in several engineering institutions. He has also served as a consultant to Philips Healthcare and as a senior project manager at IIT Bombay for smart city projects. Dr. Deshmukh has authored technical books such as Microcontrollers, Theory and Applications and Functional MRI Novel Transform Methods and has contributed chapters to internationally recognized engineering handbooks. With his remarkable contributions to engineering, innovation, research and industry collaboration, we are truly honored to have him with us today. With this brief introduction, may I request Dr. Ajay Deshmukh sir to kindly continue the session on the topic today, AI in Radiology. Let us welcome him with a big round of applause.
PowerPoint मध्ये पूर्ण नसेल दोन वेगवेगळ्या स्लाइड एनिवे you can दोन फ्रॅगमेंट मध्ये लास्ट वीक another go for another slide. So very good morning all of you. असं असतं बघा काही ठिकाणी उभं राहिलं तर काम येत नाही काही ठिकाणी गेलं की येतो. So what happens basically, the sound that goes inside, it goes to speaker and again the speaker's sound goes into the mic again in addition to my voice. So that based on how the echo is worked out. In some cases echo will not come, but the moment I go to some place then echo will happen. Because this was one project in industry. So I could use deconvolution problem and work on this particular issue where even the impulse response of auditorium has to be monitored. And once we do that, then this works fine. Then there is no problem if you go here or here also. But this itself is a big project. So we use many audio tools also in medical applications as well. Audio direction change करा होगा स्पीकर से जब और कंट्रोल में जैसे. So today we elaborate this topic on AI in radiology. Now this is a totally different game. In hospitals you find that there are so many instruments and radiology department if you see because similar lecture I had presented in College of Medical Sciences Nagpur recently, and how radiology department should come up with AI tools. And even this is also, I think some courses we have started at Nanoti Hospital where I'm collaborating for several years and getting their support also for research since 3 decades at least to our Society for Cancer Research and Communication. So here I can find out there is a lab. When I was doing research, there was no lab in the hospital. So even computers were only workstations. And you will find that in many hospitals today, radiology, oncology department, they have computer lab. Because AI has come. So you want to analyze data using AI. And many instrument manufacturing and equipment manufacturing companies, now they are trying to add on certain things. See, there is a market which is similar to automotive. Of course, automotive is a large in number, but now you find that in every square you find diagnostic center. and what type of CT scan or MRI scanner, which manufacturer, and what are the facilities. This has become a very stringent parameter. For example, you can provide some differentiator. Like our company has a noiseless MRI, where the gradient points are placed in vacuum, and then this is their differentiator. Many other companies are coming with their own differentiator. For example, open MRI. Or so the major challenge was faced when there was a shift from 1.5 Tesla to 3 Tesla for MRI. And so this is a costly affair. Of course, people they earlier used to spend 3 to 4 crores. Now it takes 8 to 9 crores for the machine at 3 Tesla, and even higher Tesla machines are also there. For example, in 2005, I went to AIMS. Of course, I had gone there several times, but in that time, this machine was for animal MRI, and its magnetic field is 27 Tesla. Small core magnet where only animals could be imaged. So there are so many good facilities, and then the manufacturers, the representatives were also there. They told me, can you? So there were two extreme requirements from two different manufacturers. One manufacturer told, can you exploit the lower field so that they reduce the magnetic field cost. Other company was telling how to effectively use the magnetic field. So new experiments, new paradigms. This is a bigger subject. I would tell you that a faculty member cannot suddenly touch the subject because I'm spending more than 40 years in this field. First 6 months are required to understand how it works. And perhaps the kind of people who can explain this very nicely are not known to many of the faculty members in engineering colleges. But it was my passion, and then in IIT Bombay somehow there is a good exploration of the research, and you can get connected with multiple hospitals and good community, research community, including Nobel laureates and many professors in universities abroad. So, this is a different game at all. And that's why I could serve as consultant to Philips Healthcare also for 1 year, and many other projects also we have done. And specifically, the newer techniques like magnetic diffusion tensor imaging was one thing at some point of time. Where, see, if you want to study in depth, this particular thing exploits the techniques of eigenvalues and eigenvectors from mathematics and control engineering. And the water molecule that is getting oriented in the direction of tissues which are diseased tissues. So that could be identified very easily by measuring the major axis and minor axis of the ellipse. So there is some sort of ellipsoid which comes in picture. So there are different types of data which are generated in MR spectroscopy. I will show you something. Routine MR imaging and angiography and functional MRI, cardiac MRI, organ-specific studies, and that too we are talking about proton MRI. There are other, for example, phosphorus MRI that may be helpful for something else like liver and maybe knee joint, bony items could also be investigated. So NMR is a very big field, and somehow many people have missed that. In fact, I was just interested right from my third year because I was studying the subject analytical instrumentation at that time, maybe the story of 87. And since that time, many analytical instruments I used to study, and then FTIR was one. So I remember the lecture. That time I could present in NCL for designing of FTIR instrumentation. So there are good number of techniques, and sometimes the machine makes use of mathematics. A lot of optical components, many other analytical instruments, they use something else. Simplest one is colorimeter, and then you can talk about spectrophotometers and atomic absorption spectrometer. So there are so many issues which we use in scientific and analytical studies. So NMR is one, and then MRI is one of the major equipment modalities, diagnostic modalities in medical imaging. There's a lot of background. I think somebody has to prepare for at least maybe starting could be from basic medical physics course, even though you are PhD in engineering, but this is the starting. You study something from anatomy, physiology, specific organ, and then perhaps you become ready to do this. And the instrumentation and signal processing, image processing, and now AI data science. This is something new. Now, what are the challenges that also we discussed? First of all, so many regulations are there. You cannot just change the component at any time. You cannot just introduce any system. So, one of the difficulties is to meet the regulatory challenges. What you do? Otherwise, there is no meaning for your work. Now, what they say is we can connect something externally. Maybe we get the data IoT and do its data analytics about the performance of the scanner imaging, and then use AI. This is one direction. You can just see here that AI is applicable. Second is for the internal. Today I am going to discuss on the internal applications of AI. Where you will find anywhere. Because it requires thorough understanding of instrumentation, hardware, physics, chemistry, and biology, in those applications, and human anatomy, physiology, many things are required in this. Then only somebody can at least talk about how AI is applicable. So I don't want to get into all the subject areas, but would like to definitely tell you where is yours and what you can do in a short time with the present knowledge and present exposure. So if you go to any diagnostic center, at least what you can do, you can spend the workflow when the patient enters and till exit time. There are certain safety guidelines. So MRI safety is a different subject. Then magnetic field, gradient fields, and the whole reconstruction is one particular area. Designing a pulse sequence for this is also crucial. Now, normally it happens in a very poor R&D team, and hardly anybody is able to do that. However, I was fortunate to get into those teams and do some work from that. And of course, I was going very big shots in this field, so that kind of exposure was possible. So, one thing for faculty member to get into all these things is to know the field. able to do assessment and give certificate. So teleradiology is a different business. So considering these challenges and volume of data, now you can use AI. I have seen how the system works in hospitals, and there are good challenges and opportunities as well. So shortage of radiologists, this is one. See, if you just see the hospital where imaging is done, so many patients are in queue, which we cannot, of course, we cannot imagine the kind of pain which they are having, and you cannot just ask patient to wait in the centers. At least 15-20 patients just go to any hospital in Pune or maybe another Jangir hospital or anywhere. You go to any hospital or diagnostic center even, to find that patients are just in queue. And if you visit like Tata Memorial and all, you find so many patients, huge crowd. All the oncology departments are full, overflowing with patients. This is also true for radiology department. So how you are going to give justice to this? People are waiting. When my number comes, at least you can tell them that you will have this much waiting time. Maybe if somebody is good in statistics, then you can evaluate how much time is required. Maybe a discrete distribution which can help you to understand this theory. If you know, you can definitely find out how much time is required for a patient. So at least they know that my number will come after some time. So there are, this is one actually, as a part of workflow, not an internal system, but as a part of workflow. If you design a software using AI, I think patients will be happy. In fact, they will not report to the hospital and just waiting there. Wait possible. Hospital ward, otherwise. So there are challenges. This is a bigger challenge, practical challenge. Where people they say that this is simple, but this is not a simple problem. Let any college in Pune, I am giving challenge to overcome this problem. It is as good as traffic problem. And so far, in spite of doing research, not a single person could find a good solution to traffic problem because it is highly mathematical in nature and lot of mathematical modeling. And people they want to minimize the mathematics, and I think that is the major problem. So you need to come out with very good tools in mathematics and find out how you can apply it in AI, machine learning, and use optimization problem to do that. Otherwise, many solutions are going to fail. So you can understand now what is the reality, and colleges are not able to do that. Even universities also. We are very unfortunate that we are not able to address our own problems. So this is a typical problem in hospital, and there are so many thousands of hospitals, even in Pune, and then you can address this problem, and this device can help everywhere. So why not use AI? Those who say that AI is the effective tool, those who praise AI, why don't you design this particular problem? Because I'm just going as per objectives, and then somebody can do PhD even in this. So what is happening to many PhD people who are doing PhD and they don't address such problem? So patient is waiting, and you don't even know that, you don't get a feel of the kind of pain which they imagine. I think this is the major problem in our research organizations and academic organizations. We don't solve our own problems. Very jawabdari. Okay, I'm just telling you at the beginning this problem. Now, as we get into the thing, there are hundreds of problems. I'm just going to tell that this is the first objective, eliminate queue of the patient and see that we reduce the scan time. Okay. Their algorithms also matter, and different pulse sequences are also equally important. And if the scan is not proper, you want repeat scan, I think that should be avoided. So, third one is demand supply mismatch. This is a bigger problem. So, number of patients, number of radiologists, number of hospitals. Find out these three verticals, how you are going to meet the demand. What you do for college admission is also same thing. Same algorithm can be effectively applied here. How many hospitals are in Pune? It's just a, I would say, it is a field research, field survey. So you just find out how many hospitals. Maybe you can do this as internship. You have so much opportunity to do internship. Just list the hospital names find out now specifically for radiology department to do, then how many and what are the facilities in radiology department, and then you can have the third column where how many patients we can accommodate per day. आता प्रोजेक्ट तुम्ही दुसरा स्टुडंटने केला नाही, आम्ही कसं इंटरेस्ट म्हणजे I want to just make it happen, and that's why we want to promote people. Unless you trigger them with this kind of challenges, they will not start working. So if you want to send a team for field work of hospitals, this is really good. Maybe corporation can encourage this and can also give some certificate. एकदा रिसर्च करणाऱ्या लोकांनी उत्तम मराठी सांगतो कॉर्पोरेशनच्या आरोग्य विभागात जाऊ आणि कॉर्पोरेशनच्या शिक्षण विभागात अनेक लोक जात असतात, पण आरोग्य विभागात कधी जाऊन पाहते सी व्हॉट आर द चॅलेंजेस. सडनली काहीतरी कुठलंतरी डिसीजचं येतं, कोविड फॉर एक्झाम्पल सडनली, अँड हाऊ पीपल गिअर्ड अप. So that time how we manage the systems, in fact that was a by default solution, but there was no proactive solution which we could provide. So two problems I have mentioned immediately, so at least maybe 10-15 PhD people can work on this, and some master students, UG students can. The story will be actually I used to get up at 2 o'clock in the morning, 2 to 6 was my research work. When you come to college, my one day was over and then next day start in a single day. So that's a different story, but everybody cannot do this. But I'm telling you that at least 1 hour history you should have done. People are just in hurry and worry, and then I think addressing the research problem, when nobody can get into the problem itself, and there is no chance that it will come across the problem. Okay, so in Pune now, so many hospitals, so many problems. This is another literature survey you can do and find out demand supply. So there is a software which you can design, and why don't you give it to corporations? They will buy it happily. Okay, or AI-based applications are extremely important. With increasing expectation. आज एखाद्या पेशंटला patient is visiting, they want that immediately the results should come, diagnostic reports. And one problem which you can handle, yesterday I told you that maybe blood sugar monitoring, go to maybe fasting and then after sometimes 2 hours lunch, go for post-prandial, and then you get report in the evening 4 o'clock. But then I cannot decide how to eat. Now I want instant reading, so people use glucometer. But now again to be more correct, glucometer is given as well. So that is a bigger problem. So why don't we have a wrist watch like thing? So it is available now, and that generates big data. So this big data cannot be understood by human beings. So you use machine learning and then have a dashboard in your mobile itself. Every time you know what is the blood glucose sugar. Of course, it has to be certified, verified, and approved by regulating bodies. There will be work. But this is one open problem. So in MRI, perhaps this is not possible, but you can dynamically record certain things, and those could also be, in addition to images, fusion of multiple diagnostic tests could also be combined. For example, there are some sequences which we trigger using ECG gating. In MRI, for example, cardiac MRI, you start the tagging sequence with ECG gating and then imaging sequence also with ECG gating, so that you synchronize the heart motion from systolic to diastolic condition in MRI itself while doing imaging with some reference, and that reference is ECG. Okay, so this is very important to synchronize the results. And then you next one. Expectations are so much. So mainly unwanted and over expectation, this can put your system in trouble. The people will be under tension, those who work in radiology department or your patients, relatives, they will also be under a lot of pressure because of certain things, and then you do not know what is happening. So expectations are increasing now. You find that imaging time must go down. At the same time, patient comforts are there. For example, we talk about open MRI, vertical bore also. So there are so many interesting things which equipment manufacturers have done. आमच्याकडच्या लोकांनी याच्यात काही केलं. So those companies are all multinational companies and their head offices are abroad. And I think they have done. आमच्या लोकांना हे का करता येत नाही हा वेगळा प्रश्न आहे. So I think people, because it requires a lot of in-depth study, at least for a period of 1 decade, and then you find the problem in that direction. So those who do consistently, they will be definitely getting opportunity, at least to solve some problems which are not internal to the scanner, but for example, queue of patients, or maybe demand supply studies, some survey of the medical applications, survey of diagnostic center, and they will give certificate also to students. I think that is quite rewarding as compared to anything else. So accurate and quick diagnostics is important requirement. Quick doesn't mean that you compromise with the quality. For example, image compression could be done, but without losing any medical or clinically important data. If you are doing compression, then I think that you need to evaluate what is the important information which you are missing at a particular level of compression. In fact, in MRI there are compression sensing imaging techniques also, where the data is recorded in compression mode itself. Even in Fourier transform also, Fourier transform which is used in MRI, the data comes in a compressed mode almost. Right? You have a single spot like thing in the Fourier domain, and then if you reconstruct, then whole space is occupied. So there are hardly maybe a few thousand or few hundred pixels which are important, and that too, if you use Fourier transform property, symmetry property, you can reduce the data to 1 point. So 400 points could be reduced to 100 even. So you get only 100 points. This is very high degree of compression which is even provided by Fourier transform. If you use cosine transform, it can have better compression. Wavelet encoding, it can get better compression. So provided you know the tools and techniques, wavelets very easily, and if you are friendly with this wavelets mathematically and also engineering point of view, then you can definitely do that. And the non-separable transforms can also perform very important role in this. So decreasing time, decreasing radiation. For example, in CT scan, the time of exposure is important. Why don't you reduce the time? So if you reduce it by 5 minutes, that is also significant thing. CT scan. I have seen people are just ignoring many times. They do not know what is the safety related to CT scan and even X-ray machines also. Of course, we introduce very limited doses, but then periodic exposure to such things can create, because these are ionizing radiation. X-ray basis. MRI is not an ionizing radiation. RF waves are not able to ionize the system. But in case of CT scan, you know, ionization happens and it is dangerous. So, but MRI has tremendous potential for soft tissue contrast and soft tissue imaging. And you know, if the experiments are performed, I think there are hundreds of experiments. I will show you so many things, and every day new thing can start. That kind of opportunity is there in MRI, provided you have engineering and scientific interest, you can use this kind of research. Reduce artifacts, a lot of motion artifacts, cardiac, even breathing artifacts. You just breathe, then we have some motion. For example, cardiac imaging, if you do, and breathing is happening, then this has to be compensated for. So motion artifacts and compensation, that itself is a big research area. Very small thing, but it becomes very big for his individual research. Next one. Some more expectation now. You want to also reduce the noise. So algorithms, maybe I'm just telling you, we will just use gradients which are fast switching gradients. There are sharp corners, and then this can create noise in the gradient fields also, because electrical switching happens in between, and then that can create different noise. So can you generate smooth waveforms? But that is one method, one way to go towards smooth wavelets and wavelet encoding. But in other cases also, you find that single shot imaging, echo-planar imaging, I will show you. So there you can use smooth gradient as far as possible. But this is a major problem. Sharp corners, the signals, which can create noise. Because a lot of energy wastage also happens in this. And the patient is also not comfortable. If you just see in front of the scanner, you find that there is a lot of noise which comes. And one solution is to put these coils in vacuum. So I think Toshiba has this kind of technology. So some scanners which are very interesting. So increasing patient throughput. Now this problem is related to the queue. For example, if half an hour is required to image, and if you are reducing this time to 20 minutes, you can accommodate more patients. There is a lot of change just by 10 minutes. And if a company is offering this solution, that scanner will have value. They can win the market. Even this is true about multinational companies who are competent enough. Latest every day they upgrade certain things. And the one which is competitive, so it is like automotive market. If small mirror adjust arrangement or if seat belt itself is not designed properly, then people will not buy that. So even if 1 rupee addition in the cost, they will evaluate in other terms. So what are the advantages which they are going to derive out of 1 rupee additional cost? So same thing is there in MRS scanner also. So people are very choosy. Those who want to buy, they thoroughly verify that, and they want to have reduction in the cost, but quality-wise, what are the comfort zones for patients and what are the facilities? So all these things are important. That means we have to be very competent. Even those who are in the marketing and sales, they need to really understand what it is. That's why in many multinational companies, the marketing people, they have at least PhD in physics, not MBAs. And this is also true for faculty members. Because you have talent, you can do a lot of marketing also. Because they believe it. I think many times what happens is I got purchase orders in 5 minutes. There are those who have MBAs and PhDs in marketing, they were just waiting for longer. Because you are technically strong. So in 5 minutes you can grab the purchase order. Only thing is faculty members should know that. So marketing and supporting, facilitating the marketing process, because marketing is directly related to R&D. And anything from customer can also improve the R&D process, provided marketing people, they know the R&D actually. For that, somebody has to be PhD and with a lot of knowledge and experience. So, how to increase the patient throughput, this is another problem. Every expectation is coming out with several open problems. And of course, we want that AI and data science can solve the problems, and there are machine learning applications. And yesterday we have positioned it properly why machine learning is required. So there are no ambiguities. Convincing people like this is using machine learning. So because it is a big data, so naturally you want to go for machine learning. Next step. So in the applications, if you just see in the radio diagnostic department, you want to integrate AI with the existing system. So you record data. One thing is for diagnostic purpose, other thing is to facilitate the radiologists and medical practitioners and managing so many images, managing the data. So RAG AI is important. So one interesting thing which you can verify dynamically is whether the same data is there. Can you confirm that this is the clear and correct data corresponding to a particular patient? Sample, for example, any pathology there also. How do you manage the sample? In case of imaging, there is a security built inside the system itself, like type of images, for example, you got header and footer which you cannot separate. Similarly, so patient specific data, once you record, the data cannot be exchanged with any other person. So it is not transferable. Similarly, for pathological samples also, this is a bigger problem. How do you ensure that the same sample goes to the hospital? Whether you can automate this process so that human intervention is not there. So this is one advantage when you go for AI agent. Of course, we will a little bit of exposure which we given yesterday also, today in the afternoon. So if you want to build AI agents or such applications, one objective is to eliminate human intervention so that these mistakes will never happen. I am just telling you very minor requirements, and you want
kind of AI softwares or AI tools which can be used in the healthcare. Suppose one student
Again,
want to use
if you use Google
for their project, which is available online.
मी तुम्हाला कालच सांगितलं की गुगल चॅट जीपीटी हे आमच्या इथे काही कामाचं बिकॉज यू आर डिलिंग विथ लाईफ ऑफ ह्युमन बिंग त्यामुळे हे सगळं विसरूनच जावं यू डिझाईन युअर ओन अल्गोरिथम which is belonging to some company and then the company will take ownership and very responsibility. So definitely you need to design your own algorithm. Otherwise they will not allow you to enter in the hospital. See, there are stringent constraints. I was dealing with regulating bodies affairs also. So there is a strict evaluation of any such thing which is covered. And anything that, because I have one company was ready to offer 1 crore rupees for the project, but then we said no because the disputes were potentially very much harmful. And that is to be resolved in the US High Court. So no professor was ready to take up this responsibility. So there are so many constraints when you do this. So many times it is better to say no. So not getting into a very complex problem. Even for company it is a problem and for researcher also. So medical researcher has to be much more responsible. Even others also, for example, if you do some system for boiler or anything that accidents, those are equally harmful. But for medical, the conditions are very stringent in many sense because those are well established. And for industry, in fact, people have not gone to that extent. So there are serious concern about how you apply the technology. In the lab, if you demonstrate something, I think it is not acceptable as it is, even though you get award. That's why I told you that award-winning projects will fail many times. त्याचा उद्देशच तो आहे award मला ते 5 कोटी रुपये लोकल because it requires bigger responsibility and then they are not able to quantify. म्हणून मी तुम्हाला सांगते की दिस इज युअर कुठल्याही विषयात फील्डिंग असतो दिस इज असे दाखवलं होतं but then nobody is able to derive proper results. So because the kind of packaging, testing, then calibration and data science if you apply, there are different protocols for that. So these are to be verified. So because of time constraint, I just tell you that AI you are going to add and then how to integrate is a challenge. How to integrate AI in the existing machine. So you need to talk to many people, radiologists, cardiologists. One such seminar we conducted in 23 in Ruby Hall. So where mathematics, oncologists, radiologists, and people like nuclear medicine, all were present. And we observed certain things that we are able to do that. Now, how do you take it ahead? So, getting data, designing experiments. So, one thing is very clear that if you do not design your own experiment, it is of no use in medical science. So, you need to design your own experiment and undergo the experiment. Maybe you have to volunteer. That's why I could record my own data because I don't know how other people will behave in side scan. They will not perform the experiment with that kind of accuracy as compared to what I could do. And many people are afraid of getting into the scanner. So they are not very happy to enter into the scanner or research experiment. But those who are doing, they should have their own experimental data. So we need to really design the experiment and then find out the results. The fourth point here is it is shifting from maybe passive to another system where we want to get into the proactive system or very active data management system. Any shift that is there in the technology is going to play even a small shift. See, there was a separate course on research and how it will have negative effect on the market. This was first time when I designed this course for Goa Healthcare Management Institute and delivered also. Because see, there was a challenge. Everybody thinks that research will have positive impact, but research will have negative impact in the market. You just add something, perhaps the sale will go down by 50%. because people will not believe. So it is necessary that you have customer education to that extent. Without which any research is going to create a lot of problem for the business. The company itself will shut down in some cases. So there are a lot of risks involved when you add something in. So if you say that now your scanner has AI and if you say with pride that this has AI, many people will not be happy with that. So we need to evaluate the research component and the performance of the whole system, considering very practical aspects, including patient education. See, normally the companies are not able to do patient education in many cases, very few companies. Same thing is true about engineering companies also. So they are really struggling to make people, customers aware of what is new in their systems. And anything new, people are not very comfortable. Always they are finding risk in that. So they prefer traditional systems for certain days. Then later on, maybe slowly it is getting accepted. And even in case of many companies, you see the business, if you add something new, many other competitors will allow you to do that for 1 year. And once you find that nobody is buying your equipment after 1 year, the company will be bankrupt. This is one way for competitors to defeat the newcomers or new research components in the industry. I have seen many companies who introduced new thing and said very good, people have they got this sort of initially, but after 6 months, it is not running and the company is doing and they are bankrupt. So there are different risks in the business which researchers should also take into account. Otherwise, your research is not working in the field. It may work in the lab or you can have some demonstration, but in the field it will be thrown out like anything and the company will be almost closed. In fact, it will become bankrupt. So there are so many challenges when you do that. Many company directors have discussed this problem with me that we have designed good instruments. They will invite people, take photographs, but afterwards they will find that this is not going to show in the market. And some directors they call it only for this field. That's why our equipment is not working in the field. So I told them the reason, and then they want people like us to position the product properly in the market. So this is one area, evaluating the research and maybe field trials they carry out. And if it is acceptable in the field, they will also conduct some awareness programs about technology, and then it will be accepted by people. Otherwise, how good is your research and technology? It will never be accepted. So many companies are contacting me for this, that if you create awareness with the customer. For example, we did a lot of programs for nuclear power corporation, E&TC and ERC. So a lot of awareness about nuclear technology. So farmers, for example, we conducted sessions for 500 farmers. Of course, their scientists used to come. Sometimes 6,000 to 7,000 people used to attend the program. I think perhaps such public kind of. In Surat also, I remember there were 7,000 people who attended the program for DRC. And I think whenever we get into the field, the technology is not immediately accepted. So you need to create awareness, and of course funding is the next part. Unless awareness is there, even though you get funding and funds are available, it will not be used by the people. So that's what I have to here. So perhaps simple regression models, AI, machine learning, which you know and which you do using the traditionally available tools and techniques, that is possible. Just for experimental level, you can verify how it works. But later on, you design your own regression model. Even the augmenting function for neural network, you yourself you can see it. So here hardly any Python program work, because there it is command-given kind of thing, and then you are not sure what is happening with the command. So you need to be thorough with mathematics. So there are 3 to 4 layers of such applications. Therefore, to design your application, you start from mathematics and then get into the physics part of that, design your own algorithm, write each command yourself. each function you can build. So you know what is the performance of the function, whether it is really functionally correct. Otherwise, many Python programs are, first of all, those are creating long codes in terms of binary numbers, and the other problem is you do not know what is happening. If you calculate Fourier transform, you know what is happening, whether it is accurate. But if the function is calculated, there are so many problems. So this is the real problem with applied areas, and it is in healthcare specifically. You need to design your own codes. Many companies will not prefer any Python program or any readily available software tools techniques because they do not know how it will be very simple with them. Optimization problems we need to handle ourselves. So unless somebody knows what is diagonal multiplier and what is the Newton's method for optimization or any other method also which you feel that it is good, it is not going to work. And here actually core research is required, right from fundamentals to applied area. And then only lab testing is not sufficient. We need to go for field trials and then see how people they respond to that. That is the real evaluation. That's why when somebody does PhD, they have open defense. They say that let everybody to see how is your research related to field or not. So if a farmer says that your research is good, then it is really good. Or if your spouse says that your research is good, then it is really good. So that kind of approach is required here. To openly say anything about public, and then to say that it is acceptable by people. So the company is happy to accept such things. Next. Yeah, so I will get into some of the technical fields based on the time. There are so many pulse sequences. Now, for a period of time, people like me can get into so many details. I can design any new pulse sequence even for any. I can show you some problem. Each pulse sequence may be costing maybe more than 50 lakhs. But one algorithm with mathematics professor has presented. Total discovery method just first time demonstrated by Professor Apar from JGM. She is a mathematician. But so I could contact her and interacted with her research scholars also. And then I understood that it is the mathematics person who has written this algorithm for mass spectroscopy. The total Hankel least-square method, STLS, stack method, and that works in mass kind of for mass spectroscopy and chemical synthesis. So now with big data analytics, we can improve upon that. But newer techniques also, some different types of testing of this data using traditional testing, but some other validation could be done and you can improve upon this algorithm. But it is amazing and very important that a mathematics professor has written this remarks which all these companies are saying. Those who are from mathematics now, this is a very good example and this will come forward. See, this is we prefer mathematics researchers initially because if you try to teach mathematics to engineering students and even after certain age it becomes difficult for them because they constantly study that. So many vast areas in mathematics are covered by mathematics researchers and students. So it is easy to do that. But today that problem will not come. Mathematics professor, physics professor, and other people. So do not worry that you do not know other areas. You can always form a team where experts from other disciplines come together and work on the project. So don't just be panic that you are not able to understand this, understand that. See, there are people, once you bring them together, then your quota is complete. And that is the complete lunch which is required for any research. So bringing the right people together is a good technique, which can easily happen in colleges. So to work on a specific, I can use several problems. Patient view, this is one problem. If you work on that, you can also work on spin-offs as you get into the research problems. But here now, I have just given you some sequences. Spiral imaging. Now here, you need to really understand the subject from practical point of view. if I want to scan the JSPM data in spiral fashion, what kind of gradients I should check? Gradient is the magnetic field gradient, maybe Gauss per centimeter. There are normally 0.5 Gauss per centimeter of this order, and you need to initially calculate. This is the setting on the scanner which you are making, and gradient in different time varying gradients, sinusoidal gradients. So now the spiral I want to generate. In some cases I want to generate ellipse, and this is maybe radially going outward vector. This kind of trajectory would also be span. Now, unless we understand mathematics, nobody is going to test this problem. And this can be programmed into the pulse sequence. So I will show you with one pulse sequence, typically single shot ecoplanar imaging, which was introduced by Professor Nobel Prize in 2003, jointly with Professor Paul Lauterbach. Paul Lauterbach in 1973, he told that gradients are to be introduced. And then Professor of Physics in ISC Bangalore, I could interact scientists in this field. So he was the motivational person and inspiring personality for Bhivarabai. Therefore, we used to explain the 100-year story and the kind of mathematics and physics very simple. Actually, members they get time to meet such people. But now I was different, and I used to meet these people and find out what we can do. And if they say you do this in a single statement, let us implement that. And then show the results also every time. So unless you show result, people will not accept the maybe kind of discussion again and again. So these are the pulse sequences. So many. I will show you some more. Next one. So many varieties of clinical sequences. Many companies, there are company-specific sequences also, like Philips, Siemens, General Electric, Toshiba. They got their own sequences. Variants of that is possible. Now, this is one skill actually. If you are a researcher, you also need skill. People they want to talk about skill development program. So in this particular area, if you are able to design a pulse sequence, then you have a skill in development. You are skilled in developing the pulse sequence. So it is very important. Pulse sequence could be sold for maybe more than 50 lakhs. For example, the technique of heart MRI, cardiac MRI, this software is costing more than 25 lakh rupees. And it starts from the clear understanding of vector algebra and matrix algebra. So that's why mathematics is extremely important, without which you cannot do this. Other thing which I told you is you want to generate some machine, design some machine, synthesize the machine from the big data. It is an open area for any of the technique. Now here it is a formula-based system. In all the scanners what you see, MR scan, they use Fourier transform. The machine calculates 2D Fourier transform and 2D inverse Fourier transform. That is how it works. So pulse sequence is not business. That's why I have mentioned specifically about pulse sequences. Of course, understanding requires a lot of studies, and maybe I can one or two pulse sequences I can explain very easily, but this is not the time. Eco sequences also. Just generate gradient. For example, what we do, just of understanding. MR spectroscopy, you get a peak corresponding to the water in the human body. Gradient combination, so that you spoil this gradient and then eliminate the signal corresponding to water. Same thing we do for fats. So if you just get into the radiologist office and water suppression and fat suppression, that is very interesting. See, the imaging is done, but now the signal corresponding to water and fat is suppressed. Chemistry people will also be interested in this, and electrical engineering people who deal with physics. So it is very clear and get into the right path. So you can design a new pulse sequence which will be more efficient as compared to the present sequence. The fat suppression problem and then the imaging so it requires something which is positive but for not be a good thing. So can we eliminate because the space around a particular organ where you find at different locations just because of the chemical shift or the chemical environment. So this is a problem related to it. How do you improve the resolution of these images? So next one. Inversion. So many layers. So all these sequences so far field attenuated inversion. So there are interesting things which you do here and here. You know, out of human body, if you just this itself is a very big concept. Same thing about areas. Okay, so there are diagnostic applications of this because Professor Dr. Damandian, the medical doctor, he designed the first lab. He is part of the medical doctor, and he told in 1997, even before that, 1945, that these processes, T1 and T2, spin lattice and spin relaxation, these are indicators of the cancerous tissue. Applications were accelerated like anything for MR and MR. Interesting observation, and it is a first order process. And this one is just like series to minus observation, and this is only technical, but then biological observation is these are the important characteristics. Pixel in the image consists of T1, T2, proton density, and diffusion coefficient. So the voxel is a things, and it is characteristics of so many from diagnostic perspective. Okay, so it is very with some new technology. I think you can grow and vertically this kind of opportunity. Anything new comes and again so together no more research, but then it needs more research. The next statement is it needs more research. Okay, so I'm just telling you some motivating factors also for this technique. Next one. This is how the pulse sequence looks like. I'm just showing trajectory. You see the dotted line which moves from point C to D, and it also initially moves from C to D. So you go horizontally, then you go maybe in a diagonal direction, inclined to axis. So this is how we want to place this trajectory depends upon what kind of next. Different. So I did to the pulse sequence level, that is another. You can slowly get into that. But here the trajectory is different. Go to some point, then go in horizontal. Okay, now there are certain limitations and advantages also. Next one. Maybe the next pulses which you see, these are seem like fragmented person, and then AI could be used to have better approximation, but in vertical direction. Now you want to move it this part as 90 degrees, and then can you generate the so people they cannot see magnetic field. How do you measure this? The method is you find out, you measure the horizontal. Initially it is in vertical direction, so signal is 0. As you flip into 90 degrees, sensor it is just kept in one side of y direction. It can be signal is maximized. Then you can first, and then AI can help you to understand that and confirm that this is a 90-degree pulse. The pulse is not 90 degree. Then there is M that means the signal is placed, not effectively measured by the coil. Signal to noise ratio will also be automatically placed, but the signal itself is placed. Of course, we go for some low flip angle imaging experiment, cardiac MRI, other MRIs also, but there is a different story. But here, this signal recorded and generated is a spin echo sequence, and they find the spin echo is very popular in very routine imaging applications. So, actually, play with these vectors like anything. Here, mathematics, which study or also. So, those kind of models will work here, and the motion of this vector in 3 dimensions is extremely useful. Perhaps that is the whole game here. So, the understanding of vector algebra and its rotation can allow you to design any sequence. Next one. Let me explore some of this. If you design one pulse sequence, they will pay you at least 50 lakhs rupees, provided you are able to manage other administrative hurdles with that. Next one. Yeah, here I am just telling you what is 180-degree pulse, and here AI can help you to ensure that it is 180 degree. Now the vector has to fill up a separate page. जे तुम्ही वेक्टर 180 डिग्री फिरवला तर अजून वेगळं applied research problems. And
previous slide of inverting pulse.
Inverting pulse.
Can you elaborate?
Yeah. Next. Just go to that.
Back.
See here, what happens is the vector is in. Now you want to move it to 180 degree. How do we do in MR scanner is we generate apply gradients and all. Then next you introduce another RF field. That RF field is the form of radio frequency for something. So it is a video frequency and bandwidth and energy. You can calculate the area under that same pulse, which is truncated. And when you apply, you if the energy is less, it will be something or 45 degrees. So based on how much energy you introduce, normally hundreds of watts of energies are introduced.
That should be in which range? Is it be in kilohertz, megahertz, or gigahertz?
It is in megahertz. For example, for 3 Tesla scanner is 120 megahertz. That is the basic frequency, and the getting signal is sin x upon x function. It is again miracle. The signal you introduce radio frequency, and signal appears in audio frequency. This is the magic because observed difference of frequencies. Just use sin cos theta. Identities. If you use trigonometry, then develop this kind of. So operation in the pulse sequence is mathematically and justified in terms of physics and engineering perspective, because you are introducing electrical energy there, and that enters into patient one. You can see for fat is different, brain is different, cerebros. Show you here there are some horizontal lines, so these are the pulse amplitudes which we need to generate, and the phase angle of the vector maybe at micro paper. So we have micro, dimensional vectors and macro kind of representation, which is summation of that vector summation. So these micro level vector, these can club together in whatever manner based on the phases. So phase angle is important here. Next one. So you can always see the sync like pulse, which is sync, and but let me come to some simple understanding. Yeah. So this is a gradient equal sequence. You can see the horizontal lines scan in a different way. See, sometimes we use raster scan like that. So it is like how we read the book. You read complete line, then go to the beginning of the next line. It is raster scan. The same way, the electron was appear moving on cathode ray tube and on TV. Now it is a different way. So it's a raster scan. So now we want to have different scans. Next one. Yeah, this is the 3D impact, same concept extended to 3D application. Next one. Next one. Yeah. Here it is interesting. Yesterday I was just trying to brief you about this, the brain. What I want is a perfect Fourier pulse and this one. So it has to be rectangular. Now, can you optimize this problem? So the pulse that is generated in the form of sync wave shape, sin x upon x and truncated version, can result into the best possible rectangle in Fourier. This you can do in MATLAB also and see how optimization problem works. And this itself is a good input for the manufacturers and designers. And then with any single example you can get introduced into the company language. You can elaborate the problems with this. So pulse generator is a bigger problem in any MRI and MR. Where initially people or any engineering people can start with just a MATLAB program and show that it is working. The electronics people can show that how it is generated through microcontroller. So it becomes a pulse programmer kind of project. We want that the amplitude and the wave shape of the pulse could be generated as per our own design. Here AI can help. Any data science models can help and better optimization problem could be handled and the electronics can generate this. So this is pulse programmer, which is very interesting. Similarly, the gradient generator is also equally interesting. Because this is, even though it looks simple, it has a lot of impact when you design something and when you start working in this. So here, the bandwidth of this sync pulse is corresponding to the thickness of the slice. And the center frequency of this sync pulse is corresponding to the location of the slice. And fortunately, MRI is we can select any oblique slice. Considering combination of x, y, and z gradients in the pulse. Okay, so there are standard sagittal is there, coronal is there, or oblique slices are there, or axial slices. That is, axis is in the direction of human body, length of human body. So axial slices. You can generate any slice, which is not there in CT scan. CT scan, you need to generate only axial slices and then process the data. And CT scan has the basic component which is consisting of basic pixel. It consists of only the density of the, I would say, the pseudo density or pure density in terms of the intensity of the radiation, X-rays, which are passing through certain things. And then, radon transform is the mathematical magic which allows you to reconstruct CT scan images. Rays of transform. So you can assign this maybe a task in some researcher or student to write radon transform algorithm. And radon transform could also be implemented by using Fourier transform. So if you have Fourier transform algorithm, you can also introduce maybe some other combination so that the same algorithm could be converted to generate radon transform. I'm just trying to elaborate certain things so you have at least 50 problems in today's session. Out of that, certain things you can take up. So So next one. Next one. Yeah, take 10 minutes. How much time is there? 5 minutes. So next, this is the. You can go to the next one. Eco-planner imaging India, Professor Phule Manasri, very brilliant scientist and professor. Now this is the sign of professor. He has introduced this. See, the problem which he addresses can be imaged the whole brain in a single shot. Just introduce one pulse and rest of the sequence, and the whole brain is imaged. Earlier, only so this single shot EPI imaging became very popular even in functional MR imaging because it makes use of the effectiveness of imaging complete brain in a single shot. So EPI images are the kind of gradient, and I will tell you some problems that map in the form of age of understanding, like where to start and how do we do that. Algorithm and electron, and then try to try it. See, the strategy is to see whenever you want to express to go for geometry interpretation. शेतकऱ्याला सुद्धा जॉमेट्री कळते. सोप्या भाषेत सांगायचं असेल तर स्टार्ट विथ जॉमेट्री. So I think it's very interesting to start with geometric interpretation. Then you back it into mathematical problem for your purpose. Do not just explain mathematics to everyone, and then you convert it into some physics and engineering, and then that becomes the synthesis of some equipment or instrument. Next, I will skip suddenly, but let me tell you that this is the EI pulse signal. You find that the signal is going in positive and negative direction as well. And this allows to have a trajectory, something like this. So start from the point, म्हणजे आपण असं खेळ खेळतो बघा लहानपणी, पेन न उचलता हे काढून टाकतो. So that kind of story. So once you start from the origin, the whole two-dimensional plane is actually you go to the final point. मी सुरुवात केली तर अजून चांगलं. म्हणजे कुठलंही टेक्निक सांगायचं असेल तर त्याला खेळ एकदा करून टाक. जॉमेट्री सांगा काही लोकांना. Then you start with mathematical expression on paper. म्हणजे ते सगळं क्लिअरली त्याच्यात लिहिता येतं. And then you do rest of the engineering business, physics, including physics. आम्हाला मेडिकलचे लोक जेव्हा म्हणतात की त्यांना सगळे विषय माहीत आहेत, पण इफ यू आर फ्रॉम इंजिनिअरिंग ते म्हणतात की तुम्ही फिजिक्सच्या ह्याच्यात पडता सगळेजण, आणि ते जर मेडिकलचे असेल तर ते क्लिनिकलच्या ह्याच्यात. सो वेदर यू आर एक्सपर्ट फ्रॉम क्लिनिकल ऑर फ्रॉम फिजिक्स, याच्यात सगळं जे तुमचं केमिस्ट्री असलं तरी ते तुम्हाला फिजिक्सच म्हणतात. हे चांगलं क्लास आहे. मॅथमॅटिक्सचे आले तरी ते फिजिक्समध्ये पडतो. इंटरॅक्शन कुड बी इझियर विथ मेडिकल पीपल. नेक्स्ट तुम्हाला काही प्रॉब्लेम सांगतो, म्हणजे हे सगळं डिस्कस करण्यापेक्षा तिथं खूप इंटरेस्टिंग करता येतं. बट विल गो टू सो दिस इज आफ्टर 2D प्रोग्राम स्टार्टिंग फ्रॉम 1 पॉइंट, then डिफरंट करता पूर्ण केस स्पेसिफिक स्टँड. ते याच्यात मला फक्त येईल की whenever this last but one waveform is changing its sign, there is another waveform which is also present, and then the combination results into this. So time varying gradients where the plane shape चे असू शकते. Next one. So this is how the serpentine type of scan we say is the imaging. Next one. Well, the variants data. Next one. Yeah, you can see the gradient waveform. तुम्हाला सांगितलं की जेव्हा वरचा waveform 0 आहे तेव्हा दुसरा एक waveform. It is only present when the upper gradient waveform is 0. आणि हे मॅथमॅटिक्स म्हणजे जॉमेट्री मधून आलेलं आहे. तर याच्यातून आम्हाला काय मिळवायचं आहे तर we have a single shot imaging first of all. The next is we can generate different types of scans for the way in which case space is spanned. Next. The mathematics began to be next one. Next one. Next one. Next one. We can go to the last 2-3 slides. तुम्हाला केमिकल शिफ्ट इमेजिंग बद्दल सांगणार होतो स्पायरल इमेजिंग हा घेता बिगेस्ट see what I am doing is this is just expanding cosine and sine wave with the same frequency त्या frequency बदलल्यानंतर वेगळं काय होतं mathematically but geometrically and specifically trigonometrically this is very easy to understand so if I generate this kind of x and y gradient then it will span trajectory like this next one हे बघा ते तुम्हाला स्पायरल क्रिएट झाली हे इतकं इंटरेस्टिंग आहे त्यात स्किल आहे आर्ट आहे इंजिनिअरिंग आहे सायन्स फिजिक्स मॅथ्स सगळं अँड देन केमिस्ट्री इज ऑल्सो देयर each of these is very interesting for imaging for organ specific imaging so if you design a pulse sequence for example I am designing for cardiac MRI very special sequence for imaging this cardiac tagging yesterday I showed you functional MRI also, very different method of experiment also. So you can design something new like this and then take inverse 2D Fourier transform to generate brain image or any organ specific image. See what I am trying to understand here is basically what I have to give to a programmer or design engineer is if you generate waveform like this, gradient waveform, then you get this pattern. And then you have two-dimensional signal process. Next one. So this you can have better with AI and data science application. Next one. So next one. So why spiral? Why we need this? Let us focus on this one. We can improve this one. For example, better ability to flow article. Blood flow is there, and that can also create some. Also in a different way. So having a different geometry in the case space can improve certain things. Therefore, we go for different geometry. Next one. Yeah, this is the point. Just go to the previous one. If I want to go for this kind of case, something that is going in positive direction. Now I want to shift it to the negative direction of K1. Then what kind of waveform is this is one. They have given the pulse sequence also. So if you want to generate this trajectory, that means the kx, ky plane has to be inclined through certain angle theta. The rotation in spatially two-dimensional spatial case-space domain. This is because of some requirement of imaging, and therefore this problem arises. The next one is, can you generate this kind of spiral we have seen. Now you generate so many different types of ellipses. So concentric ellipse, number of ellipses you can generate concentric. So what kind of waveform is required? And these problems are very tricky. एकदाही विद्यार्थ्यांना दिले की ते सोडतच नाही त्याला शेवटपर्यंत. Very interesting. त्याची competition लावायची. And then mathematics people, physics people, chemistry people, you can evaluate solution. Next one. See, this is the waveform that can generate something. Alright, the geometry actually very started. Initially with 0, when we start from the peak of the sine wave. And then here we start from the sine waves. That generates circle. Or get expressions of the pattern. It is very interesting that you come up with different trajectories and AI can help you to understand. So for example, if the relation is not understood, you go for some regression model. Now machine learning advantage is you are able to fit the relationship, input-output relationship dynamically. So you don't worry about non-linearities and other problems. So today it is becoming very simple to use machine learning and regression models to fit the relationship. And then perhaps I don't need to write the formula. त्याच्यात मॅथमॅटिकल ॲडव्हान्टेज असा आहे की मला त्याचा फॉर्म्युला लिहिताच येतो. म्हणजे जे आम्हाला असं कळत नाही त्याचा फॉर्म्युला लिहिता येतो. सपोज आय टू आस्क व्हॉट इज द फॉर्म्युला फॉर दिस लाईट. आता हा फॉर्म्युला मला AI मशीन लर्निंग वापरून सोप्या पद्धतीने लिहिता येतो. सो इट इज जस्ट रिलेशनशिप अँड द डेटा which you can correlate with between input and output. So that becomes the formula. म्हणजे आम्ही नेहमी फॉर्म्युलाच दिला पाहिजे हे नाही. त्याच्यामध्ये आम्हाला AI वापरून मशीन लर्निंग वापरून इनपुट आउटपुट रिलेशनशिप दाखवता आली पाहिजे ग्राफिकली. दॅट इज ऑल्सो गुड इनफ बिकॉज यू कॅन ऑलवेज इनपुट दॅट रिलेशनशिप. प्रत्येक ठिकाणी मल्टिप्लिकेशन फॅक्टर वेगळा आहे ते तुम्ही देऊ शकता. It's just like the lookup table that is now replaced by a dynamic regression model, and this is very much useful even for many engineering applications when you write program in the embedded system. Okay, so coming back to the last slide, next one. This is typical of sinusoid and form grading. The formula-based approach looks good provided you are able to deterministically write the formula or statistically. Now, once you say statistically, it gets into the machine learning and AI-based models as well, or inferential statistics sometimes. So, methods which are already there have been now maybe extended to AI machine learning kind of approach. So, yesterday I told you that whatever you do with present system, you apply AI machine learning, that becomes a newer part. So, coming to the last one. Yeah, if you want to generate this, how we will do that? Very simple geometries you do. Perhaps MRI reconstruction module, you can just understand how it is mathematically also, and understand how it is. Maybe there are separate programs on this, and people can do wonderful job as far as the internal design of this machine is concerned. Next one. Next one, if it is there. Yeah.
Main switch off the main switch.
Generator. Then it is goes over. I will do as much as possible. So mind will work. And sometimes it is good that electricity is not there, so that you get peaceful type of thing. Yeah.
Actually, I have a lot of questions, but I will ask one. You have explained the situation where heart and that pulse graphs can be altered. What can you say that actual challenges will be faced or will face in medical industry of applying this technique?
Mainly regulating bodies approval and introducing this as a part of design. Because whatever you do, you need to present in front of R&D engineers, take permissions, and they should allow participate of regulation. So the challenging thing is regulation. Then the company will be eligible to do any modifications. After that, you can get it. But if you want to do it, the best way is to join their head office team. Then get a chance to do something.
Sir, how much accuracy is there we are using in healthcare? It's a very crucial
This
field.
we need in micrometer level. Normally, the dimensions of pixels, typically in MR spectroscopy, those are 0.5 centimeter cube or slightly lesser. 0.1 centimeter cube, you can say, in the plane. Very small region. So for that, micrometer accuracy, or at least multiplied by 10.
Can we compare with our any other whatever the output which are coming from AI? Can we compare with that result? Can we compare that result with anything? That's whatever the AI output which is coming, how much we can depend on that AI result?
No, every time you need to validate first of all, that is one. So secondly, accuracy could be less or more. That is not a problem. But it has to be reliable and the results have to be confirmed. For example,
you need to verify the data and say that this data is correct. Any data mining you do or apply any filtering, you need to find out whether the meaningful data is getting filtered out. See, sometimes you know that the frequency of signal and frequency of data is falling in the same band. Then how do you, this is a correlated noise. Sometimes how do you work out that?
Sir, as you said that can we take one image of the brain? Okay, so this is a question. To AI, suppose we have given image of brain, it will give you information. Okay. But how we can take this matter to business level for earning money by considering that gradient echo sequences and brain information?
See, actually we have to get into the company understanding, non-disclosures and all. And once we are comfortable with the company and establish the relationship, then certain things will be done. For such research, people like me can facilitate. कारण तुम्हाला ते असं सहजासहजी घेऊन जाता येणार नाही. See, if you see some of the confidential cases where already I have reputation and understanding trust, they will entertain us. If I go with one or two people, they will accept. That is how faculty exposure program works. For faculty, they will allow easily because they know that these people are not going to be competitor for them.
That is the main reason.
And of course, it is not possible for anyone to build such a big scanner and start doing things with that. So for innovators, there are so many challenges in this.
Thank you very much, sir, for the informative session on AI in radiology. You addressed various challenges and how AI and ML can assist radiologists in analyzing large volumes of medical imaging data, such as MRI and CT scans. The discussion on workflow management, image reconstruction, and improving diagnostic accuracy with mathematics was extremely valuable and inspired participants from various disciplines. Thank you once again, sir. Let us give a round.
Wish you all the best for your research.
Thank you. I request Dr. Y.S. Angal, sir, to felicitate our esteemed resource person. Dr. Ajay.
Thank you.
Thank you, sir. Before we proceed to our next interesting session, we'll take a quick 5-minute break and come back. Thank you. Just a 5-minute break.
5 minutes break.